Around the workshop, there are a number of jobs that I've simply not tackled because I don't have the equipment. And some of those include, for example, re-truing the jaws on my 4 and 3 jaw chucks off the Colchester Student lathe. Also, I need to do some work on some of the L0 tapers of my Colchester Student lathe. And then there are other types of work. So, for example, regrinding drills. I've always done this by hand, but sometimes I'm aware of the limitations of that. I'd like to be able to regrind end mills and also face mills like this. And occasionally I have need for a one-off high-speed steel lathe tool, which needs to be accurate, and I'd like to be able to do that properly. So all of this implies that I really need a cutter grinder and a tool post grinder. Now I think that I might be able to do this, both a tool post grinder and a cutter grinder, from some common elements. So for example, I'm thinking of the motor, the spindle and the drive could be common to two machines, and then have a separate base and work holding devices to make up the cutter grinder. So let's have a look at some drawings before we proceed to make the first parts. So this is just a simple layout showing my tool post here. This is the top of the handle operates the turret tool post. Here's the spindle. This is the outline of the motor, and this is the larger diameter pulley. Now, in designing something which is going to be used both as a tool post grinder, and so I need to hold small wheels, as well as a cutter grinder, I need to have quite a range of speed. So this shows the highest ratio to drive a small internal grinding wheel. This is the tool post, and I'm going to use the tool post to clamp the tool post grinder onto the lathe. This shows another view. So although it's shown here with a cup wheel, which is a bit inconsistent with this pulley arrangement, but anyway, this is part of the design process. I'm going to have a sort of yoke which goes around 3 sides of the tool post for adequate clamping. The tool post grinder is going to be clamped with a kind of I guess like a kind of jubilee clamp that goes around the outside. Now, one of the first items I'm going to work on is this clamp, and that's because I haven't got the bearings and the oil seals yet. Just a quick look at the design of the spindle. So we've got a solid steel housing with 2 magneto bearings with spring preload on there. I'm going to use a poly V-belt on the end here, and we have interchangeable tool posts, much like a corn cutter grinder actually. That's the general layout. I have some materials here already. So I've got some EN8 for the body, also for the end caps. I have some EN19 for the spindle, although I might have to get a larger diameter piece of steel because I've slightly changed the design. And I've just got some mild steel here for making the clamp. And I'm actually going to start on the clamp today. I find it difficult to know exactly what to include in videos. Sometimes I think perhaps I show too much machining. So on this project, what I'm going to do is just show a summary of the machining, I think, because there's simply going to be too much material otherwise, and it's going to be too slow and laborious to get results. But we'll see. It appears that the work has moved, but it hasn't. I recentered it to make sure that the chamfer was concentric with the diameter. So because I'm going to use the profile of the 3-inch diameter bar for this section here, the offset of the hole needs to be fairly precise. So I've marked that out, and I've measured the center of the hole here, and we're going to bore that out now, not to full size, but we're just going to drill a pilot hole for now and bore that out. We're going to use that for setting up on the mini machine. So I've marked that out. What I've got to do is get the face square, but also get the right degree of offset. So I'm just working on that at the moment. It's a little bit fiddly. I'm not going to go through the whole thing with you. We've got that running central, and now we need to check that this face is square as well. And then we'll just double check the concentricity again. I think that's good enough. Since there's a lot of stick out from the chuck, and there's a reason for that. That's so that I can center and square everything. I'm not going to plunge a 1-inch drill in here without first turning a pilot hole. So I'm just going to bore that out maybe half an inch to 1 inch, and then we can use the drill to remove the rest of the material. Just done a quick regrind of this 1-inch drill. Of course, it's done by hand, so it's not perfect, but it's certainly cutting a lot better than it was before. It's not quite cutting equally on both lands, but better than it was, and the original was as it was supplied. So my hand grinding is actually better than how this drill was supplied. So I brought the work over to the mill, and I'm going to work now on this surface here, and this top one, and this lower one. And I might also take a little bit of material out of here. Later on we're going to produce this external radius, but for now these three surfaces, possibly that one. I've cut out this material here, which is just really about weight saving. I don't like to have excess material on components like this. Really, I just want the material to be there that needs to be there. These steps here are really just roughing out operations to remove excess material before profiling this outer radius, which is going to be a more delicate operation. So it's quicker to do that with the setup there using the vise. The radius I'm talking about is this radius here, this outer radius, from this tangent all the way around to where the bolt sits. Now what I didn't show when I was doing the turning was that actually this bore is a tapered bore, and it's got a slow taper in there, something like a Morse taper, and I made this mandrel which fits in there like that, and we will use this mandrel to hold this in the dividing head and using a tailstock support, and we'll use that to profile that outer radius. So we'll go over to the milling machine now and have a go at that. The machining of that outer radius is coming along nicely because these are roughing cuts at the moment, but I have just rotated the work to 40 degrees to cut this taper here, which is the taper where the screw boss merges with the radius, and you'll see that on the drawing. I'm taking very careful cuts because this is only wedged on, but I'm also ensuring that the direction of cut is forcing the work onto the taper. Because end mills have a slight clearance underneath, in other words, they're only really cutting on the tip, it means that as I rotate the work, I'm actually cutting a series of slightly convex surfaces, as you can see here. So what I've been doing is I've been finishing off with axial cuts. It's a bit boring, but lots of axial cuts, and that's cleaning this up nicely, as you can see here. And I'm going to go ahead and do a bit more on the center section here. It's cosmetic really, but if I'm going to do the job like this, I might as well do it properly. Well, this should be the last operation using the dividing head, and I'm just chamfering the corners. Well, I have to admit that took a lot longer than I expected, and I'm glad to have the work on the dividing head completed. I'm going to spend a little bit of time now deburring and cleaning up these surfaces, and then we can move on to the next set of operations, which will be more conventional. Okay, we'll push this arbour out. That worked very well. There was no sign of movement whatsoever, so it'll be interesting to see how much force it takes to push this out. Well, there we are. A lot. Am I doing it the right way? Let's double check. Yes, that's correct. Yes, that's really wedged in. Okay, we're going to have to heat up the body, I think, to get that out. After a bit of deburring, careful filing, and a little bit of rubbing down with wet and dry, and yeah, it's dimensionally accurate as well. One mistake, which you can probably see here, there's a slight dig in. As far as I'm aware, that's the only mistake so far. What I'm going to work on now is the counterbore here, or partial counterbore, for the 2 set screws for clamping. So we'll go over to the mini machine for that. Well, that's all we have time for this week. Made a good start on this clamp. Next video we are going to attach this to the angle plate for boring, and then it's going to be slit. There's some drilling and tapping to do, and we've got to make the yoke which holds this in the tool post on the lathe.